Hello everyone, today we are going over some Blind 75 in C++, and today we're working with subtree of another subtree. Now before we get started, make sure that we have all of our 4 questions that we have laid out to be able to make sure that we know how to solve the problem by breaking it down. We need to first ask ourselves what the input is going to be, what data structure / algorithm / technique to use, what to do with the data, and then what our output is going to be. So, just to break down on the problem, given the roots of 2 binary trees, root and subroot, that's already self-explanatory. We answer the first question, and you can also look at the parameters. What we have tree node 1, tree node 2, 2 roots of 2 binary trees, root and subroot, are returned true if there is a subtree of a root with the same structure and node values of subroot and false otherwise. Alright, so we already know what our output is. A subtree of a binary tree is the tree that consists of a node in a tree and all of the node's descendants. The tree could also be considered a subtree of itself. Alright, so that would be just one edge case to further consider as well. The tree could also be considered a subtree of itself. And so what we will be doing next is then just going over the example that we have. So it looks like that we have, so if we have the root of one binary tree and then the root of a subtree accordingly of a subroot and then a root, we're checking to see if these values are matching. So that's all we are doing. Values from the subroot are matching any of the subtrees from the root of the binary tree. It's pretty self-explanatory, and then we return true or false, just seeing if these nodes accordingly within the root of our binary tree have the same values as the following right over here. So just to be able to break down even further, the technique that we will be able to use to be able to solve this problem is that we're going to be doing a recursive approach to check if one tree is a subtree of another. And what we will be doing with our data, aside from checking, we will traverse the trees recursively, comparing the nodes and their subtrees. So then what we will be doing next, I'm just going to be going over the steps of how we will be solving this problem. And let's just double check for case of that. Yep, it's pretty self-explanatory between examples 1 and 2. Checking to see if these subtrees have accordingly the same type of numbers already between the subtree as well as the binary tree. Now this example may have the subroot values, but then we have this 0 at the end that will also expand upon 2. So if we were to break down how a binary tree works for the most part, it typically would start with the root, then you go left, then you go right. Then what we will do is that from the left side you go left and then right accordingly, and then so on and so forth. So if you have right, then you do the left of the right, and then right of the right, and so on and so forth. That's just the general pattern that we would have, such as 3, left, right, and then we will have left of left, left, right, no, yep, this indicates for 5 accordingly, and 1 as well. So that's why we have this null, this is for 5, this is for 1, but then we have 0 over here for 2, which would be right over here. It's left to left. And this will not work because of this 0 that we have. So self-explanatory. Now, just to go over the steps, first thing that we will be doing is that we will check if T is a subtree of S by calling a recursive function is subtree. S and T. Define a recursive function is subtree S and T to check if T is a subtree of S. If either S or T is null, will return true if both are null, indicating an empty subtree, or return false otherwise. And then we're going to check if the current nodes of S and T are equal. If they are equal, call the isSameTree function to check if the remaining subtrees are identical. If the subtrees are identical, return true. If the subtrees are not identical, we're going to continue searching for T as a subtree in the left and right children of S, and then we'll return the logical OR of the results obtained from the left and right subtrees. Next thing we will do is that we will define a helper function is same tree, which are P and Q, to check between if two trees, given hypothetically, P and Q are identical. If both trees are null, return true. Then if either tree is null, or the values of the current nodes differ, return false. Then we're going to recursively check if the left and right subtrees of both trees are identical. We're going to return the logical AND of the results obtained from the left and right subtrees. Ultimately, just having the then we're just going to return the result of the calling the isSubtree function on the given trees. So now just to be able to write out the code for each of the steps that we would have, we're given the input. Now what we will do is that we're going to do something pretty unique. So we are going to do a recursive call, as stated before, is subtree S and T. Then we're going to use this part to be able to make our recursive calls. So we're going to create two.
We can probably put them in private as well.
Excuse me. So I'm going to create this first recursive call function of boolean is subtree helper tree node S and then tree node T. Make sure it's all spelled correctly. Then we will do yes. If S equals null pointer and T equals null pointer, we're going to return true. Given the fact that they're both the same, that's our first edge case that we will deal with. since they have to be the same, if s equals null pointer or t is equal to null pointer, given the fact that they're different, we're going to return false. Now that we got those, checking. All right, step 4, checking to see if they're equal. If s val equals t val, and this is the part where we're going to be creating our is same tree type of function. So that means that this will be step 5 accordingly, and if is same tree, we'll construct more of the other function that we will create, and then step 6, we're going to return true, given the fact that we have determined that they are the same. And then step 7, if the subtrees are not identical, continue searching for t, which means that will be return is subtree helper, s for the left side, and t or is subtree helper. On the right side, t. And now for the next part, we are going to be doing this next function. Boolean is same tree for 2 hypothetical ones, just for the sake of the parameters. So this is why we do this. P and then tree node Q. And then we'll be doing step 9 all the way through. Let's go or this is step 7. Step 8. Step 9. Step 10 will be if p is equal to null pointer and q is equal to null pointer. We're going to return true, given the fact that we have found out that they are similar. Then for the next part, step 11, where this will be false. Pointer or q is equal to null pointer, or the value of p does not equal q's value. Then we're going to return false. And then what we will be doing is that we will be doing a recursive call. So step 12/13. Again, similar pattern that we have done already before. We're going to recursively check and then do the logical AND operator. So that means it's going to look like a return is same tree. P's value on the left, Q on the right, and P on the right, Q on the left. And for step 14, return the result of calling is subtree function on the given trees, which is also the same as step 14. So let's just double check on this whole thing. Let me just make sure all the syntax is correct. I'm going to move all this up and just put this in the comment section to be able to help you folks see the whole solution and walk through each step. Okay. Let me just run, and if there's any syntax errors, I apologize in advance. Okay, there is a syntax error that we have. Let me just double check to see what it is. Okay, so actually, this error that I have is supposed to be on the direct left, and then we have right as well. Unlike that, okay, so the logic that I was supposed to have is not left and right. It's supposed to be on the values of the tree on the left side that we compare, since we have two different trees, as well as on the right. So this explains why we're getting this wrong error. All right, it passes all the test cases. I'm going to submit. And it works pretty well. Okay, so just to give a breakdown on the space and time complexity for our following solution. The time complexity for our solution is going to be O of m times n, where m and n are referring to the number of nodes in the trees S and T, respectively. And then in a worst case scenario, we may need to compare every node in S with every node in T. While the space complexity for our solution is going to be O of max of m and n, where m and n are the heights of the trees S and T, respectively. And the space is using a series of recursive calls to represent the maximum depth of the recursion stack that we have. Hence, it would be constant, but since we are using two types of trees, we have the subtree as well as the binary tree, this is why we have them multiplied, as well as just figuring out the exact max between them when talking about the time and space complexity. And yeah, this was Subtree of another Subtree. Thanks again for taking time to watch this. If you found this helpful, like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.